Good morning, my dear friends. How are you? Today, I will give you the basic knowledge about the SR flip flop. Okay, so let's have a look. SR flip flop, uh, if I tell you something about this, then you should be knowing that S means set and R means reset. If I draw the proper diagram of this SR flip flop, it will be like this: S, R, Q and Q bar. Okay, and here this is the enable signal. Here S for set, R for reset, Q is this output and Q bar is the complemented state of the output. Okay, now what happens key, I can show you that this SR flip-flop can be designed using NAND gates. So if I'm going to use 4 NAND gates like 1, 2, then 3 and then 4. Okay, so here it is the feedback, and here let us see that this is gate 1, gate 1, gate 2, gate 3, gate 4, and here the gate 3 and gate 4 are commonly connected to this enable input En. Okay, and this is R and this is set. Sorry, sorry, let's rub it. So this is for set. Okay, so this is S, this is R, this is enable. Now these are the inputs. Okay, now Q2, Qt plus 1 is the next state and Q bar T plus 1 is the complemented state of the output. So these are the outputs. So I can say that S and R are the inputs. They are being applied to the gate number 3 and 4, and outputs are given as Qt plus 1 and bar Qt plus 1. So actually what is this diagram telling? Actually this is a clogged SR flip-flop. What is it is known as clogged SR flip-flop. Okay, in this clogged SR flip-flop, we know that this is a synchronous SR latch. We can also call it as a gated SR latch, right? Now, when two more NAND gates are added to the basic SR latch and one more input called enable is added, we get a gated SR latch or a level triggered SR flip-flop. Okay, here you can see in addition to the two NAND gates, more two NAND gates are added and one more input. This is the input enable. It is being added. So this is known as gated SR latch, in which two more NAND gates are added to the basic SR latch. Okay. Now let us discuss about the excitation table and the truth table. We know that truth table has all the input combinations for which the flip-flop reacts to produce the next state output. Okay, flip-flops will respond to the inputs if and only if we applying active enable at enable signal. Here this is an enable input, and if we apply an active level at enable input, it can be either 0 or 1 depending upon the type of the flip-flop. Now let us look what should be the output, and then we will discuss the excitation table today. So see, inputs are enable input, S, R, and outputs are QT or QT plus 1. Okay, sorry, QT plus 1 and Q bar QT plus 1. Okay, these are the inputs E, S, R. Now case 1, when the enable input is 0 and S and R it are not applicable. When E is 0, so S and R won't be active. So output will be as it is. That means it will be depending upon its previous state. So it will be Qt and Q bar T, right? Because it will show no change condition as this enable signal is 0. Okay, let us look. Here, this is the truth table. I'm sorry, you can see this is the truth table, right? I can show you S, R, and this is Qt and Q bar T. Now look, second case here, if E is 1, this enable signal is high and let the S and R inputs are 0, 0. Again, what will happen? The same output will be generated, Qn, Qt and Q bar T. Again, because as no change, okay, because S and R are 0. Now, second case is, again the enable signal is high, S is 0, reset is 1. So, Qn plus 1 will be reset means 0. So, Qt plus 1 will be 0. And this complemented state of the output will become 1. So, this will be known as reset condition. Similarly, when enable is 1, we get S as 1. If it is 1, it is 0. as we have two inputs, so there will be how many combinations? Four possible input combinations: 0, 0, 0, 1, 1, 0, 1, 1. If S is 1, then Qt will be 1 because S holds for set condition. And the Q bar will be, Qt plus 1 bar will be 0. So this is set condition. Now again, if E is 1 and S and R both are 1 together, so this will be race condition. This will be known as race condition. In indeterminate state, it will be known as. So you have to avoid this condition. Okay. Now, what we can do, now we have to generate the excitation table. Excitation table mainly depends upon the truth table. Okay. So excitation table consists of the two columns for the present state and next state, and one or two columns for each inputs. That means excitation table means, if I can write it as excitation table. Excitation table means it is known as the minimum inputs, the minimum number of inputs, okay, that are necessary to generate a particular next state, or particular next state they are going to generate qn plus 1 or qt plus 1, minimum number of inputs necessary to generate a particular next state when the current state is known. When current or present state is known. When present state is known, and mainly this excitation table, it mainly depends upon the truth table of the SR flip-flop. Okay. Now, if we just calculate the truth table, now I am writing the truth table also. See, here you have what? Again, if I write it as like this way, normal truth table, okay, I can write it as TT. Now clock is 1 and S, this is clock signal, right? Clock. So S, R and Qn plus 1 or Qt plus 1. Next state, 0, 0, 0, 1, 1, 0 and 1, 1. So 0, 0 mein it will be having only memory, no change. No change. It will depend upon its previous input, whatever be the input it was earlier. Reset 1 is 0, set 1 is 1, 1, 1 may invalid condition, right? Now we will draw what? We will generate the excitation table according to the truth table, okay? So first of all, you should be knowing the truth table, okay? You should be knowing the truth table. Now, truth table means, now what we have to do, first we have to generate the characteristic table. Characteristic table, okay. For qt plus 1, characteristic, you have to write down the characteristic equation. You know that the next state qt plus 1, it is a function of the present state q1 and inputs s and r, right? So if you have, you can write it as qt, s and r the inputs, and qt plus 1 the outputs, right? Here this is the output, and this is the characteristic table below here. And here what we can say, as we have given 3 input conditions, so we can have 8 possible combinations: 0, 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so we have 8 possible combinations as we have 3 given inputs. Now what will happen, that since this qt is 0, okay, this is the previous state, and qt plus 1 is the next state, this is the output. So it will give, as SR both are 0, so it will give only 0, as qt is 0, so it will be equal to 0. That means it will be depending upon the present state, previous state, qt. Now when 0, 1, reset is 1, set is 0, and again q is 0, then what will happen? Qt plus 1 will be 0, right? And now when it is 1, 0, set is 1, reset is 0, and what will happen again? As you can see from the truth table, set is 0, R is 1, so output will be 0, like. And now when set is 1, R equal to 0, then Qt plus 1 will be 1, right? Now when 1, 1 is there, so what will happen? S and R both are 1, then it will be having invalid condition, that means cross. Again when this qt is 1 and again 0, 0 are the inputs to S and R, so what will happen? Thus qt plus 1 will be depending upon this qt only, that is it will be equal to 1. That means the memory that was stored in qt will come to qt plus 1. Now again when 0, 1 is there, so 0, 1 again So output will be 0. Okay. When 1 0 is there, as according to the truth table, when 1 0 is there, then output will be 1. When 1 1 is there, then it will be in valid condition, right? So this is the characteristic table. So first three columns of the characteristic table are for the inputs. These are the inputs for QT, S and R. Okay. In these columns, we write all the 3-bit combinations from 0 0 to 1 1. Now, I can just here mark as the table, right? So this is the what characteristic table. Now what will I will draw? I will draw excitation table. Excitation table that will be depending upon the characteristic table. Okay, now excitation table of SR flip flop. It will be depending upon the characteristic table. Now what will happen, as you have seen, uh, see, you have present state QT, you have next state QT plus 1. You have Sn as input, you have Rn as input. So these are what? These are the two inputs. And these are what? This is present state, this is next state. Now 0 0, 0 1, 1 0 and 1. Now, as you can see from this table, when 0 0, present state is 0 0. When present state is 0 0, then SR was present state is 0 0. Here you can see present state QT is 0 0 2 times and QT plus 1 is 0 0 2 times, and these are the necessary inputs for the excitation table. Necessary inputs, that means you can say from the characteristic table we observe the table like this way. So Q8, QT is also 0, QT plus 1 is also 0. So S is 0 0 and R is changing condition from 0 to 1. So it will be don't care condition. So here it will write as SR 0 and X. Rn will be X. Right? Now QT is 0, QT plus 1 is 1. Now QT is 0 and QT plus 1 is 1. Again you can see QT is 0 and QT plus 1 is 1. So you can see from here that S is 1 and only you can see from here when QT is 0 and QT plus is 1, then S is equal to 1 and R is equal to 0. So here we have S is equal to 1 and R equal to 0. Now QT and QT plus 1 are 1 and 0. QT and QT plus 1 are 1 and 0. That means here it is 1 and here it is 0. Again you can see that 0 1 when QT is 0 and QT plus 1 is 0. So here S and R inputs are 0 1. So here we can write here 0 1. Now when QT and QT plus 1 are 1 1, that means here it is 1, here it is 1. And what you can say, uh, it is also QT is 1 and here it is QT plus 1 is not given. You can say that S is 1 here but R is changing its value, or you can say see QT is 1 and QT plus 1 is 1. Again where it is 1, as you can see from this table, here it is 1 1 1 1 condition and here it is 1. Okay, so you can see here SR is 0 0 and here 1 0. So here S is changing condition from 0 to 1 and R is constant, it is 0 0. So here it will be cross 0, don't care condition. So this is the excitation table of SR flip-flop. This you might have studied. If I can write the combined table, if I write the combined table, like I can tell you like this way. This is the characteristic table. As you can see, QT, QT, here it is QT plus 1 is output. For characteristic table, QT and SR are the inputs and we are just drawing its table. This is QT plus 1 is the output and we have all the 8 possible combinations 0, 1, 2, 3, 4, then it is 5, then it is 6, then it is 7, right? Okay, now again I'm telling you QT plus 1 was what? According to the truth table, if I can write here truth table 0 0 0 1 1 0 1 1. So here S and R was input and it was invalid condition. Set was 1, reset on 0, it was no change. Now when S and R are 0 and QT is 0, so QT plus 1 was QT. I'm just making you revise. Reset 1 is 0, so it will be 0. Qt means it will be equal to 0, Qt plus 1. Now set 1, so Qt plus 1 will be 1. When 1 1 is there, so it will be cross. That means it is invalid condition. Now when again 0 0 is there, so it will be depending upon the Q state. That means it will have memory. 0 1 to reset is 1, then output will be 0, set is 1, then output will be 1, 1 1 is there, so it will be invalid condition. Now we have to write the excitation table. For excitation table, we can write here it as, I'm just making you revise, it is like qt plus 1, and here Sn input and Rn input, right? Now what you can do here, 0 0 0 1 1 0 1 1. Now you have to determine the S and R conditions, S and R input condition depending upon the present state and the next state of the Q output. So when 0 0 is there, so you can say when 0 0, here S and R is 0 0, but when Qt is 0 0 and Qt plus 1 is also 0 0, so what is the S and R? 0 0, right? Here when Qt is 0 and Qt plus 1 is 1, then what is the condition of SNR? Qt is 0 and Qt plus 1 is 1. Set 1 and R is 0. So here it is 1, 0. Now when Qt is 1 and Qt plus 1 is 0, this is 1 and this is 0. And again, you can say it is 0, 1. So it is 0, 1 condition. Now when there is 1, 1, it is 1, it is 1, it is 1, it is 1. That means these two conditions are, we have to keep checking. So here this S and R are 0 0 and here this is 1 0. So R is 0 but S is changing condition from 0 to 1. So that means it will be don't care condition, and it will be from 0 0, it will be 0 0. One more thing, sorry. Uh, Sorry, one mistake has to be corrected. When Qt and Qt plus 1 are 0 0, this is 0, this is 0, right? And this is also 0, this is also 0. So S is 0, R is 0, right? S is here 0, R is 0, but R is changing condition from 0 to 1, so it will be don't care. So this is the revision, right? So this is the excitation table of SR flip-flop. This you have to remember, and this is the characteristic table, right? So I think actually I have joined university in Pune, so I will be taking less classes. So I think that I will take only 1 week, one class. Okay, so please cooperate, and I will tell you I'm taking the subject digital logic design. So whatever I'm teaching there, I will be imparting knowledge here on this YouTube. So please cooperate and please like, share, subscribe. Thank you very much.